So, hello all together, and thanks for having us today. So, you might have recognized the title. We borrowed it from a similar named movie, but we don't steal cars with AI and take even longer. No, that's not the reason why taking the label. We are working with monthly stats because the demand forecast in the car industry is based on monthly stats, and we recognize some repetitive patterns. That's why we said gone in 30 days. Thanks for the introduction, but I would like to add something. Eva is working as a project manager, project leader in the Digital Solutions division. And therein she's designing and carrying out innovative projects to hold the market position of Porsche in Austria, basically. I myself, in the role as a business developer, caring about the design of data-driven marketing projects. And what this match resulted in will be the subject of today's presentation. And we'll guide you through a whole project now, which we conducted the last year, from the beginning to the end, so from the identification of the problem to the solution. And Eva will now shed some light on why they were motivated to take the data-driven approach for their problem.
Okay. Well, prediction is very difficult, especially if it's about the future. With these words, I would like to start this presentation, and I would like to welcome you to this afternoon session. Within the next couple of minutes, Sebastian and I will guide you through a project that was done in cooperation between the Know Center in Graz and Porsche Austria in Salzburg. And the project is about setting up, designing, implementing a forecasting tool for a company in the automotive industry. This company is called Porsche Austria. Porsche Austria's business is mainly to import cars of different brands. Those brands are VW, Audi, Seat, Skoda, Porsche, Bentley, Lamborghini, and Bugatti. And yeah, well, that's the main business of Porsche Austria. And what we hold is a market in Austria where you have around 350,000 new car registrations in 2017. Thereof, we have around 120,000 registrations of Porsche Austria brands, mainly brands like VW, Audi, Seat, and Skoda. To give you a little bit of more insight into the market in Austria, we hold a share of around 40% in Austria, which is, I would say, quite very well. And if you have a look at the Austrian market share of the top 20 brands, we find VW, Seat, and Skoda within the top 3 ranked brands in Austria. In order to keep this position, of course, we have a market research department at Porsche Austria, and they are very keen on trying to estimate sales numbers and registration numbers of cars in Austria for the upcoming months.
I guess every one of you has already seen this process, the CRISP process, so an industry standard for data mining. We slightly adapted it, and we followed this process throughout the project. So basically starting off with a business understanding, which also includes identifying the design problem, which was coming up with predictions in a new manner, then acquiring the data, exploring it, preparing it for then the later steps, which are located here, so the data science steps, how they are called. And then later on, when you have achieved an insight and came up with models that are usable and really bring interesting results, you integrate it into a software solution or the workplace and then evaluate it. And this will also be the table of contents of today's presentation, so we will follow it up and tell you something about the individual steps. So Eva, please, something about the domain understanding and the design problem that we faced.
Yes. As said before, we have a market research department at Porsche Austria, and they have a bunch of tasks to do, of course. They do reporting, daily, weekly, monthly reports. They do support the sales planning departments of the different brands we have in-house. They do special analysis and evaluations, for example, for the supervisory board in-house. And they also have an eye on the European market of different car brands, how it evolves, how it develops, and so on. And of course, they are also dealing with projections per decade. So it's 3 times a month they do projections of or estimations of car sales within the next 10 or 20 days. Forecasting in our market research department started more or less 30 years ago when young Willi Reichel, you see his picture over there, joined the team in the mid-80s. They started with a very basic forecasting tool, let's say. They used plain sheets of papers and a calculator, and they estimated the numbers manually, let's say. Ever since, it's more or less a one-man show, because forecasting very strongly depends on this one guy, our chief forecaster at the department, let's say. Of course, he involves his colleagues in these forecasting techniques, but I mean, he has a knowledge of over 30 years, and it's not really, cannot be really given to someone else in this way. The tools that are in use at our market research department are on the one hand very basic tools like Microsoft Excel or Microsoft PowerPoints. They use these tools mainly to do tables, to do estimations, calculations in a very extensive way. They use PowerPoint for presentations and for reporting, also for designing sheets, report sheets. They use SAS. SAS is a tool for processing, analyzing, exporting data, and of course they have a very big database management system in their background, where they have data from, let's say, the early 1940s until today, so they have a huge library of reports and yearbooks. Projection in this department is a very strong combination between human knowledge of over 30 years and IT tools, supportive tools. And I think this will also stay like this because we are very strong emphasizing this combination of human and tool-based estimation and forecasting. The main problem, of course, that you could guess is that what will happen if Willi once leaves the department or the company because he turns 60 within the next couple of years. And what will happen then? Of course, we have to prepare for this, and we did this around 2 years ago. And we thought about how can we counteract this problem, or these problems that may come if Willi once retires. We wanted to have a tool that observes the market and also our competitors on the market, of course. We wanted to have a tool that keeps an eye on our position in the market to strengthen our position and maybe also to boost our position, to influence planning and sales departments of the different brands we have in-house, and to reach goals and keep the market share. Why do we have to do this? Of course, the implicit knowledge that is linked to more or less one person is lost sooner or later, or maybe lost sooner or later. We would like to have a democratization of knowledge so that everyone can handle different tools and can generate those estimations and forecasts. We would stay with this combination of human and IT support, and we would also emphasize on the knowledge that is machine generated just as a support for those guys who are doing these estimations. How would we like to reach this? We thought of cutting edge technologies, of course, data-driven forecasts, because we have a lot of data storage and a lot of database management systems where we can use data from over 60 or 70 years. And we would also keep the predictive accuracy, of course.
This led us to the following project idea, to co-design a market forecast tool and co-design collaborative design. I think you know the term. We really collaborated from the beginning until the end of the project. So together identifying the design problem and then collaborating together until we found a proper solution that can be put into practice.
Well, we thought of a co-design approach between Nocenter and us, in order also to estimate the demand of new cars, the demand of new registrations within the future, within the next months, let's say, or up to 1 year.
For these estimations, we then used historic market data of the registrations clearly to make the best use out of this data for the predictions. Yeah.
And within our approach, we would like to focus on easy handling for all guys within the market research department, not depending only on one person anymore. A good understanding and a good handling of this tool.
And one challenge was also to leverage current state-of-the-art methods, so to say neural models were applied, and we tried to come up with hybrid approaches of classical and neural models, but we'll tell you some more in the next steps. So first was the data acquisition after identifying the design problem. So we identified all the available data of the market research division and also externally, and then selected the relevant one.
The first step, data acquisition. Well, we scanned through our different data sets and data management systems, and we finally identified a few data sets that are relevant and also available in the different times or time rows that we have to use in order to do predictions. We use data from the new car market. This is, first of all, the number of first registrations per month, the numbers of first registrations per decade, so every 10 days in a month, and the first registrations per model per month. We also use data from the used car market, so the used car registrations per month and also the deregistrations per month. And finally, we also use external data, external information concerning the working days per decade. So every 10 days, how many working days do we have? So this also influences, of course, the sales numbers of our different dealerships.
In the next step, we explored the data that we acquired. This means we made different aggregations on the car type level, on the brand level, on the model level, and also for the whole market. And thereby, we first descriptively analyzed the data. So on the left graph, you can see there are the 72 months data set that we had available. And you can see that the most of the brands range in between 0 to 2,000 registrations per month. And you can see there are also some outliers performing much better than the rest of the market. So we thought like, oh, there is a high variation, so let's look into this variation in some more detail. So we conducted some confidence intervals to just see in which interval most likely the registration of a brand will vary over time. And first, clearly, the outliers were reflected also in the big confidence intervals, but a second thing could be identified here. You see that that's some kind of a pattern over time, so a seasonality which was indicated in the data naturally. So we thought, let's look into this variation or this seasonality a bit more. And so we chose a method, autoregression, which helps you to identify such repetitive patterns then also on the individual brand level. On the left-hand side, you can see a very strong manifestation of the seasonality by the spiky waves that are flowing from the left to the right of the diagram. On the right side, it's a much less strong variation, but you still see a little bit the seasonality. Over all of the brands that we analyzed, the seasonality was, for the most of them, relevant, or we could identify it in the data. And this basically was somewhat the design idea, to look at methodological approaches that respect this seasonality, because we thought like they will perform better in the data science steps. So we prepared the data that we collected, which means we handled the missing values, for example, ingested the data in our analytics pipeline, and then analyzed it in more detail. In the field of predictive analytics, there are basically two fields that you can look at, the linear methods and the nonlinear methods. On the linear side, you have regressions. On the nonlinear side, you have the machine learning models, the neural models, which we will already heard today a lot about, and we will hear tomorrow much more. This is the set of methods that we looked at when testing and making the predictions of the future. You see that there are some linear approaches, so the regressions, different versions of it, and we also had the neural networks, for example, the feed-forward network. But as I said, the idea was that seasonality plays an important role in the methods, so we said, let's take some methods on board which specifically respect the seasonality. And you can see that there is the autoregressive integrated moving average method, the ARIMA, or SARIMA, sorry, no, I said it wrongly, the seasonal ARIMA, SARIMA model. This is specifically a linear model which is made for such seasonality. And on the other side, the recurrent neural networks with a long short-term memory specification, which is also made for such seasonality. We analyzed the data then in splitting up the data set that we had available in a data set that could be used to train the models, and a rest of the data set which was then used to compare our predictions to the actual value. So how good did we perform? Then we took two different approaches for evaluation. On the one hand, short-term prediction, so always just predicting 1 month in advance. This was actually what was the most important thing to make the car imports, to base the car import numbers on top. But we also said it's important to mark the long-term predictions. So if you predict 3 months in advance, you already have 2 predicted months as part of your data set. So you're basically making the predictions partly on artificial data that you generated yourself based on the predictions. These are then already the results that we gained. Let me explain you them in some detail. Here are the short-term predictions, here are the long-term predictions. So clearly, first, we computed the models. Afterwards, we computed the error metrics. And as a last step, there were some more in between, but let me simplify it a little bit. At the end, then we computed, we depicted the error metrics as part of box plots because they are just very easy to compare. We chose 3 different error metrics: mean absolute error, root mean square error, which is very standard error metric, also already handling positive and negative signs. And as a last one, the mean absolute percentage error, which is easy to interpret as it's just percentages that can be used, but also the maze, which is not depicted here. But you can see that the linear method, the SARIMA method, performed better with a lower error metric over all of the 3 error metrics over the whole data set, aggregated over the time and aggregated over the brands for the whole market. This means overall, the linear approach performed better than the nonlinear one. Here the same for the long-term predictions, but just aggregated for all over the time and over the brands. This means that for the individual brand predictions, the nonlinear models performed also not performed in some cases better. So they had different characteristics. While the nonlinear models, for example, need a bigger data set, the linear approaches can handle smaller data and still perform very good. And this was indicated by the better results for the whole data set. So we chose both methods actually to go on and decided for the SARIMA model on the linear side and chose a second one on a nonlinear method, the recurrent neural networks. And we also made this combination. You might have recognized that here on the right side we have hybrid, and I didn't explain this yet. We thought, like, if you have 2 methods and they are like complementary, so you can maybe cope with the downsides of the one algorithm by combining them and making a hybrid approach, which is basically very common in recommender systems research. So we decided to give this a try and try it out. After we now identified the models that performed well, we said, okay, now we have to integrate it in practice in a way that it's really helpful for Porsche. And what is the most important person there at Porsche at the moment? It's Willy. So it doesn't make sense to simply come up with a tool which presents just one value and the people can just orient and then determine the import based on that. It's important to give the people the chance to learn and understand the market as Willy did it. So it was important to not just deliver this one prediction, but come up with a tool that allows the people to understand the market and learn the same competences as Willy had. So we said, let's come up with an interactive dashboard so that the market could be understood by the new predictors or the new Willys, let's say it. Okay, this graphic basically repeats what I've shown you up front. It gives an indication of how the green bar is the nonlinear method and the orange bar is the linear method. You can see that again over all of the error metrics, with maze is just a scaled error. It's even better for the combination of comparison of methods. So the orange one performed better over the whole data set again. This was quite helpful for the people from the market research division because they could get an indication which is, on average, the better performing method. However, you could also clearly, and this was the goal, look into the individual fabricates, look into the individual brands, and get then the specific predictions. Here you can see again the training data set. So that's which was used for training the data. And later on, you can see how the training data, the test data is compared to the predictions of the models. And later on, clearly, these are the predictions then into the future. So you could really move through this graph and then get the individual predictions also to get a higher usability and be able to compare the individual metrics. And again, the hybrid method was in between, clearly compensating the downsides of each. But it was then not, or if you would just use that, you wouldn't have the best hit and you wouldn't have the worst hit. So it would be somewhere in between, not making a really wrong decision. Scrolling down, you would get the error metrics over time. And this is actually very interesting because you could see how the error metrics, if they are stabilizing, at what point they are best. And actually, we figured out with MAPE, you can see that after 5 to 6 months, the best predictions are reached, and they are somewhat stable. So the error doesn't get more. So we arrived at the error of, I think, 10% something. And the correlation at the end was just another way to look at it by correlating the predictions with the real data, and you could see after 4 to 5 months, the prediction here after 6 months, it was the highest correlation in between both. So what take-home messages could we say? Machine learning is not always the best approach, especially if you don't have the biggest data sets. This is one thing you should keep in mind. On the other hand, the deep learning approaches that we used here could even perform better over time if the data set gets enhanced, because the data is collected also and will be collected. So maybe in the future predictions, the machine learning approaches will even increase in their performance. Then it's important to combine the right methods. It could be that, or we're thinking about making a recommender which then chooses based on the characteristics of the data the right approach, so that just one algorithm is then proposed and you don't have to make the comparison yourself. And there's a chance to explore the performance of that hybrid approaches as well. Maybe they are even the percentage of how they are weighted to each other are then maybe even automatically determined.
Well, for us, let me speak of the market research department. For us, it was very important to have a benefit of this project. And the benefit, of course, is that we have co-designed a tool that is really usable for the market research department, because every one of those guys can use this tool. So they don't have to explore it, they don't have to learn it. They can quite easily upload data via buttons, and this is really the essence of this. We have a highly sophisticated, I would say, tool, a combined approach between linear, nonlinear, a hybrid approach. So we really take the best out of it, and it's easy handling for our colleagues. I think this, I would say, is the biggest benefit from this project. And
for example, we also included an automatic mechanism when you upload the data that it's checked for errors, so that you don't arrive at wrong computations. So this is automatically done in the background and signaled then to the worker in the marketing division to then be able to cope with that.
Yes. And finally, it also allows us to make reports and very punctual predictions, as is stated on the button of this slide, for further decision support. So we are able to do very flexible reports on demand whenever we have to do it. If the supervisory board says, okay, we need this and that. So we really have a tool now that fits our requirements very well.
Maybe one more comment to the co-design character. it literally meant that we sat around the table, so the domain experts and the methodological experts from KnowCenter, and we also can or have to make steps back in such a co-design approach. So it's always iterative. If you can fail, learn from the failure, and then make one step back. 2 words more to the KnowCenter, which is located in Graz. So we are basically an incubator for data scientists of tomorrow. We educate them from bachelor, master to PhDs as well. The disciplines that we are bringing together are quite diverse, from business to also understand the GDPO, to linguists, to psychologists, all is covered, and the competences are from prototyping in the data science area to also data security and data management. On the partner side, we have small to big partners. You see some examples at the side, and what's quite interesting, we have our own funding scheme to fund interesting, innovative data science projects. And surely we also rely on some third-party funding and acquired over 30 EU projects in the past. If you're interested to talk about data-driven marketing projects, I'm happy to take them. And let me give you, as a last word, some credits to one of the team, that Matthias Traub, who can unfortunately not take part today. He is one data scientist himself, and he participated in the project from the beginning to the end, and some credits to him at this point as well. So, thanks.